Hello, Techno guys. By this time, you must have gone through the video lecture on Lighthouse project at Ranchi, where precast concrete construction in a 3D volumetric construction form is the technology being used. In the e-module, we have also given you enough reference material in form of audio-video films, lectures, presentations, books, compendiums, performance certificates, circulars, etc. And it is recommended that you must go through them and use them frequently, because this collection of reference material at one place you won't be able to find anywhere else. So keep a copy of it and use it in your future endeavors and to understand more about the construction systems. Having gone through the lecture, there must have been several questions doubt in your mind. In order to answer your queries, what I have done here is that based on my experience and interaction with various stakeholders at various platforms, I have created a FAQ in the presentation form, and through which I will be answering some of the common queries. Most of the queries when we interact with the stakeholders are broadly divided into these 8 areas, starting from cost to structural performance, functional performance, joints, connection, to the capacities in terms of professional agencies and workforce. So I have prepared one slide on each of them, and through those slides, I will try to answer the queries. So first and foremost is the cost, but before that, let me just briefly give you the project details. In Ranchi, we are using this precast concrete construction, 3D volumetric, where 1,008 houses are being constructed in G+8, which is 9-story, and the total project cost is 134 crore. And let me also tell you here, this is for the first time that this kind of 3D volumetric construction is being used at such a large scale in India. So the first question is, what about the cost? So if I compare the cost of the awarded project at LHP at Ranchi, the per flat cost, including infrastructure, using this 3D volumetric construction is 13.29 lakh as compared to the cost which is 11.83 lakh with conventional technologies. This is 12% higher. And why it is coming higher? Because as I told you that for the first time, we are using this 3D volumetric construction in India. So that is one thing. In addition to this, there are a couple of other factors which have direct implication on the cost. And these factors are: what is the size of the project, what is your location, the geoclimatic profile of the region, which includes wind velocity, earthquake, flood, and other natural and man-made hazards. The soil strata is also very important, because that will decide the type of your foundation. And then availability of material in factory. If you have most of these innovative construction systems are based on factory setup. So if you have a factory setup in the vicinity, then cost will definitely come down. Otherwise, you have to set up a casting yard, and the cost of that casting yard will be loaded on the cost of your project. Then accessibility, because here we are using 3D volumetric construction, so accessibility, you require wide road and you require heavy equipment and machinery. So the site should be good, and you should be able to install tower cranes and other heavy equipment at the site. So all these factors will also have direct bearing on your cost. Also, one very important thing is the critical mass. Critical mass is nothing but the minimum built-up area or minimum number of houses required so that the technology become economically viable. This is also known as economies of scale. So, if there is no demand, then you require at least minimum number of houses so that technology can be compared with the conventional one. Also, once there is a demand, right now these technologies are at the initial stages where a few projects are being done, and that's why we are doing this lighthouse project. Once there is a demand, then the cost will automatically come down. Also, please note here that these new technologies come with several other advantages and several other benefits, such as resource efficiency, environment friendliness, energy efficiency. Embodied energy is less. They are cost effective in the long run, and these enables faster construction. So when we talk about cost, we need to talk about all these things as well. So initial costs may be slightly higher, but overall, when we, over the lifespan of the building and in terms of environment, in terms of energy consumption, in terms of economy, in terms of optimization of materials, the cost is much less than compared to conventional constructions which are in vogue. Next is the structural performance. So here I would say without hesitation that the performance is quite superior, because majority of work, if I have to say 90% of the construction is taking place in the factory. And so here we can say we are not constructing building, we are manufacturing the building, because the entire construction operation is taking place in a factory in a highly controlled condition, where each component is being cast properly, each joint is being cast properly, and services are being put properly. And it's like going to an automobile industry where you put parts of automobile one by one, and at the end you get the car made. In a similar fashion, here the building is being made. You are putting components of building one by one, and at the end you get the entire building. So this kind of factory made manufacturing of building under strict quality control and supervision ensure superior structural performance as compared to conventional cast in situ RCC construction. Further, because it's a concrete construction, we are using high performance concrete. There is proper reinforcement, and that reinforcement is detailed properly. There is accelerated curing through through autoclaving. Then there is proper cover, dimensional accuracy further adds to better the structural performance. And in all these systems, structural integrity and monolithic action is ensured by proper joints and connection. Whether you connect module to module in a vertical direction or in a horizontal direction, whether you can connect module to foundation, whether you connect wall to module, all these can be done in wet and dry joint form, and therefore you ensure proper structural integrity and monolithic actions. Also, both kinds of joints are possible in these kind of system. When you are connecting modules to modules, modules can be cast with plates and double bars, and then these plates can be welded together to connect module to module. Also, when you are doing this 3D module, some of the walls are left and which are cast for all the modules, and then all these modules are separate wall is being cast and then connected through double walls. Also, when you are done with one floor, the slab over slab, you put a screed on a reinforcement, and then those reinforcement bars can be connected with the double bars of all the modules so as to have structural integrity and monolithic action. So absolutely there is no problem as regards structural integrity and monolithic action, and you can achieve all through these dry and wet jointing, and through combination of this dry and wet jointing, and through this double bars, reinforcement splicing and cast in situ concreting monolithic action, and you can have moment resting connections which will ensure good seismic resistance. Also, nowadays sophisticated structural analysis tools are available along with the efficient design, which will further help ensuring better structural performance. Also, remember that bad execution will lead to poor structural performance. So proper execution with good workmanship and strict quality control and assurance measures will further help improving your structural performance like in any other construction. Because precast concrete construction is always thin because you're using high performance concrete. So the structural elements, the thickness of wall and structural elements are less as compared to conventional construction. So the questions are being raised on thermal efficiency and fire rating, durability, etc. So let me tell you that because we are using a high performance concrete here, and it's a precast concrete element, so it's dense, it is impermeable, and it is high performance, so it helps in improving thermal efficiency. But at the same time, because it is a concrete construction, you need to have some passive measures, including proper orientation, ventilation, doors and windows, including climatic responsive design, will help improving thermal efficiency. Also, fire rating, then you need to comply with national and international standards, and based on those national standards, the thickness and reinforcement can be decided so as to have a desired fire rating depending upon the purpose for which the building is being used. Construction being done in the factory, so strict top class quality control as regards concrete. So these structures are durable, and there are almost no joints here because the entire module, 3D module, is being made in the factory. So these are durable and requiring less maintenance. Compatibility with conventional finishing items is there because all doors, windows, tiles, your plumbing line services, they can be fixed in the factory. And so what you get is pre-finished module from the factory, and all you have to do is connect them together and start using them as a building. Life cycle cost is low. I like to tell you something about life cycle cost. Let's not talk about only initial cost, which is cost for construction, but talk about the cost of building in terms of three things. One is initial cost, which is cost per square foot of the construction. So that is construction cost plus the maintenance cost of a building, or the cost incurred during the service life of building, which will have your maintenance cost, your energy cost, and other costs. And third is the disposal cost. So that these three costs, disposal cost plus maintenance cost during service life of building and initial cost of construction, these three added together make life cycle costs. Life cycle cost of such building is low, and that is what is required. You need to have low life cycle costs when you are dealing with when you are comparing it with conventional construction. Okay, so these 3D volumetric construction ensure low life cycle costs. Also, 90% of construction being done in the casting yard or offsite or in the factory, which will definitely lead to better structural and functional performance, and there is optimization of material leading to better functional performance. Joint and connections, as I told you, any kind of joint and connection is possible here. You can have dry joint, you can have wet joint, you can have mechanical joint. So the technology providers, and depending upon their technology, they are using all these kinds of joints, and they also use a combination of these joints, because in India we have it's a seismically prone country. So depending upon the zoning, depending upon the loads you are getting, you can have combination of these joints. So normally there are three types of joints. One is a dry joint, where you fix up plates with double bars in the modules which are cast in the factory, and these modules are bolted together through nut and bolts, or welded together with the packing plates. That is one kind of joint. Another kind of joint where you can leave double bars in all the modules, and then connect these modules through grouts and through welding of those double bars. Another joint is where you leave some walls open in these modules, and then cast those walls separately and connect all the modules together through that wall. Another connection kind is where you have once you lay all the modules, then all the modules are connected at the roof level with a separately partially precast the roof, and laying over ice screed with reinforcement. So any kind of joint is possible, and the overall objective or purpose of these joints and connection is to have monolithic action and structural integrity. So in 3D volumetric construction, structural integrity and monolicity of the entire structure is possible by properly doing joints and connection design. Okay, and another thing I want to tell here, that when we are doing a wet jointing, that is better, because the dry wall connections are suitable for panel walls and floor systems. So dry joint and wet joint, the mix of that would be better for 3D volumetric construction. In any construction which we do, there has to be proper design of all the joints which are coming, whether it is module to module, whether it is module to roof, whether it is module to wall, whether it is roof connection, whether connecting modules side by side. So proper design of each joint is to be done beforehand, depending upon the structural analysis result, and these joints need to be made depending upon requirement, moment resisting and shear resisting, or both. And detailing is also very important, because you need to refer to 13920. It's a ductile detailing code, and even you have to refer to some international standards, so that when you are putting the reinforcement in your precast concrete construction, how the continuity of reinforcement is maintained, how the splicing is being done, what is the size of the stirrups you are using, what is the spacing between the bars, how horizontal and vertical bars are being connected. All these are part of detailing. So detailing of joints is also very important when we deal with these kind of systems, and proper design and detailing will further help avoid brittle failure of connections in case of an earthquake or any other load. 3D volumetric construction, it comes under precast concrete construction. So recently we have two codes on the prefabricated concrete construction, which is IS 15916 2010 and 15917. The first code gives you building design and how to erect and how to design your building, and for using prefabricated concrete, and 1597 is for mixed or composite construction, when you are using RCC and walls of different kind. So these two codes deal with the precast concrete construction. In addition, we have National Building Code as well, 2016, which mentioned 3D volumetric construction. But as such, there is no dedicated code on 3D volumetric precast concrete construction. So we need to refer international standards, the American the ACI codes or Euro codes can also be referred. And BIS, Bureau of Indian Standard, does allow referring to these international standards, in case of non-availability of Indian standard. Also, the BMTPC issues performance appraisal certificate for 3D volumetric construction. We have so far not issued any certificate, but for 3D, for 2D precast concrete construction, the BMTPC has also issued performance appraisal. Also, this technology has already been shortlisted by our ministry, by Ministry of Housing and Urban Affairs, and it is one of the technology of global housing technology. CPWD also has recommended this technology for future construction work. So, as regards certification, as regards total provision, there is absolutely no problem. In case of non-availability of Indian standard, you can always refer these circulars, these performance appraisal, and this shortlisting by the ministry for your use in the field. These all technologies come with their dedicated software, customized tailor-made software, but 3D volumetric construction, it can also be modeled in ETABS, SAFE, or other softwares, and you can carry out any kind of analysis depending upon your requirement. So design aids are available, codal provisions partially available, but there is enabling ecosystem which will help you implementation of technologies. The field schedule of rate for this is available. And because primarily it is a concrete construction, and so you can use these codes for load calculations. The 1893 is for earthquake, and 875 for other loads other than earthquake load. Then for RCC, National Building Code 2016, which is compilation of all the codes that can be referred, and the Bible for RCC construction is IS 456, which deals with mixed design, which deals with fire rating, reinforcement details, and all those kind of things. There is another very important code which is important and is 1786, which is the code for steel bars. So that need to be referred. And because we are using high performance concrete, so one is 10262 is also very important to be referred for concrete mix design. And 13920 is for ductile detailing. This also is a must-have code because when we are doing a construction in zone 4, zone 5, or for that matter in any zone, ductile detailing code need to be referred time and again for proper design and detailing of your reinforced concrete. Okay, so foundation here again we are using a conventional foundation. Normally it is a footing. Normally it is done on a raft. So for raft 2950 is the code. Otherwise for shallow foundations or deep foundations we have separate codes which are also written here. Additions and alterations, yes, here you can't do any addition and alteration at a later stage because, as you know, the building is being manufactured in the factory, and at a later stage, if you want to do any addition, you have to cut through the concrete which is already laid. So it's very difficult. But if in case it is required, you have to do it with the help of the technology provider, with the help of the expert. And let me tell you, these additions and alterations will be very expensive and time consuming. Okay, and also these additions and rotation at the later stage will directly affect your joints design and affect your structural performance, because here everything is decided before, and all connections and all those things. So doing it at a later stage is not advisable. So it is difficult to do additions and rotation. Also, from my experience, let me tell you that particularly in concrete structures, any addition and alterations without giving proper thought and without referring to original drawings and doing the analysis design, in case of earthquakes, these buildings with additions and alterations at a later stage perform very poorly during earthquake. And it was found during Bhuj earthquake that most of the buildings which were later modified, they didn't perform well. And obvious reasons are because you are changing the load paths of your building, you are doing connections improperly, and which will there will not be any structural integrity and monolicity between what is done originally and what we have later added. So connection between the addition, what you are doing, and with the old concrete is also difficult to do if you don't seek the help of the experts. So once you don't connect the old portion with the new portion, there will be absence of structural integrity, and all these things will lead to failure of your building in the event of the lateral. Although it may look good when you are adding something as far as vertical loads are concerned, but a slight shaking of ground will make your building very vulnerable at a later stage if you do the additions and alterations without the help of an expert. Maintenance of services, yes, again, very difficult to do it here because you are doing the services and in the factory, but in case of any leakage and malfunctioning at a later stage, you have to refer the manual, and you have to do it through a standard operating procedure, which is normally given by the technology provider. Okay, but at the same time, it is recommended that we need to do the regular preventive maintenance of our building, which includes checking of lines, conduits, cleaning of clogged drains before the onset of monsoon. Then water flow, if there is any leakage, that need to be immediately attended to. So regular preventive maintenance is required for this kind of factory-made construction. And also we need to follow a standard operating procedure, which is normally given by the technology provider in case of any leakage or malfunctioning of your services. But it is difficult to repair. Also remember that whenever we are doing any repair, so the grade of concrete is also very important. So repair work has to be done with a concrete which is of higher strength, and plugging of joint is with the high performance concrete, and with a specially made out is also necessary, so as to have structural integral action. Capacities, yeah, there are very few companies. If I tell you now that there are very few companies which can be counted on fingers for who are dealing with this kind of technologies at present in India. But the clarion call given by Honorable Prime Minister of Atmanirbhar Bharat and Make in India There are more and more entrepreneurs, new entrants, startup industries are joining the construction sector, and there are very, even youngsters. There are, few youngsters who we said, just by passing out from the colleges, they are joining this 3D volumetric construction. I know a couple of them. And in times to come, we will have enough agencies who will execute these large scale projects, and there will be a healthy competition. As regards capacities amongst professionals for designing and supervising these projects, yes, very few professionals exist at the moment, but concerted efforts are being made at the government level. We are also running a course Navriti along with the School of Planning and Architecture, through which we are trying to inculcate knowledge about these new innovative construction system in the professionals. Also, this e-module of for technograhi is targeted to create a widespread awareness and sensitization amongst technograhis, so that they can get the feeling of these technologies, and they can know the various nuances of these technologies, and later on can implement them in the field. The overall objective of for building capacities is to get these innovative systems included in the academic curriculum of universities. That is the next step which we are going to undertake, and once it is included in the academic curriculum, the engineers and architects who are coming out of fresh engineers and architects who are coming out of colleges will have first-hand information about these technologies. And this is a specialized system. Let me tell you, precast concrete construction being done in the factory, so you require a special set of skill, and therefore trained skilled manpower is necessary. And but at the same time, let me also tell you that the manpower can also be trained, and most of the agencies they impart on-site training to the manpower and make them skilled so that they can work in their project. Also, unskilled labor which is being employed in the project require a little bit of training to execute the projects of this kind. Another important thing, because 3D volumetric construction, so you have to you transport them to the site, then properly stack them at the site, and then over already laid foundation, you have to put these modules one over the other with proper alignment, proper hoisting arrangement, and with proper handling of all these equipment. So you require heavy equipment and machinery, and for handling, transportation, erection, and assembly. So with this, I hope I am able to answer some of the queries which I come across through various interaction and through various lectures. But in case, I'm sure you must be having a couple of other questions as well. So you can write to me on my email ska@bmtpc.org, and I will definitely respond to your queries to the best of my capabilities. So thank you very much.